These are the questions that you must do. I am holding each line very carefully. Show that number 1 point, limit this. Show that means you need to use the classical definition. I have done these problems. Do it with the classical definition, the formal definition, these questions with formal definition. Then this here to just use the limit because the limit is existing. So you have to use the hint is you have to write limit. The right hand limit is equal to left hand limit. In the right hand you need to put at x equal to 1 you need to put this, and in the left hand you need to put the above function and then equate and you will get the value. You have to check whether the limit exists or not. Sorry, find the limit. I was talking about this problem where the limit is already they are saying exists. In order to find the relation between a and b, you will have to write limit x tending to 1 plus is equal to limit the right hand limit is equal to left hand limit, and then you will equate the two things, and you will get your relation between a and b. This question I have done. This question also I have done. This type of questions I have done. This type of questions I have done. So now scroll a little bit down. I'll just hold again there so that you can, the video is there. Just a minute till here. Yes, we will then this type of question I have done. This is done. This question I've solved for you. This also I've solved for you. Now this you will do it yourself. These many questions are there for you. Now let's do another question. Wait, I hope you are able to hold the video here and see the questions, copy the questions properly. That's why keeping the videos static at this position so that you can copy the questions. What you do is that you stop the video here, copy the questions, and then try to solve them on your own. Now we will go to the next part of this thing. Question. Now there is a good question. Question is limit x tending to 0 sine inverse x minus tan inverse x upon x cube. I need to find this limit. Now see one thing, this is sine inverse and tan inverse. There is no formula which relates. ऐसा कोई formula नहीं है जो sine inverse और tan inverse को relate करे. तो क्या करो, sine inverse x को write sine inverse x equal to y. X is sine y. X is sine y, that means x by 1. So now you make a right angle triangle like this. This is your angle y. Sine y means this is your perpendicular and this is your hypotenuse. Use Pythagoras 1 minus x square. So now what you have got is tan y. Now you will get tan y. You will get tan y. You will get tan y. Tan y equal to perpendicular upon base. Now you will get y equal to tan inverse x upon under root 1 minus x square here. So this y is equal to this y is equal to this. Therefore, limit x tending to 0, you write 1 upon x cube here, put a bracket. Instead of sine inverse x, now you can write tan inverse x because sine inverse x is y and tan inverse x is also y. Therefore, sine inverse x is tan inverse x upon under root 1 minus x square minus tan inverse x. Now do one thing. Wait a minute. Let me take this whole picture and let's delete this. The whole thing is gone. Now what I'll do is that I will use this formula. Tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. This formula, this will behave like x, this will behave like y. So now you have limit x tending to 0, 1 upon x cube, tan inverse, you write down x under root 1 minus x square minus x upon, wait a minute, upon 1 minus x under root 1 minus x square into x this way. I've used this formula here. Now this becomes, let's take, wait a minute, let me draw this line properly. Draw this line properly. Yes, now it's okay. Now you take LCM. See, now you take LCM. Here, this is equal to limit x tending to 0, 1 upon x cube, tan inverse. You write it very big, x minus x under root 1 minus x square, and then you have under root 1 minus x square upon, wait a minute, I did a mistake. This is okay, fine. You're taking an LCM only. That's right. With under root 1 minus x square. Now you need to make this bracket bit big one. Wait, make this bracket little big one. Yes, upon under root 1 minus x square upon under root 1 minus x square. This cancels out. So what you are left with, let's go down. What you are left with, see, what you are left with, just a minute. Yes. Yes, now you are left with tan inverse, limit x tending to 0, limit, limit x tending to 0, 1 upon x cube, tan inverse x minus x under root 1 minus x square upon under root 1 minus x square, and this, now consider this as x and write this below this, x minus x under root 1 minus x square upon under root 1 minus x square, this one, and multiply here with the same thing, x minus x under root 1 minus x square upon under root 1 minus x square. What I did, whatever was here, I divided and multiplied with the same number. जो भी यहाँ लिखा हुआ था इसके अंदर, उसी नंबर से वही चीज मैंने यहाँ पे और यहाँ पे मैंने फिर से लिखा. That's the thing. This will behave like total x. This will behave like total x. This will behave like total x, and limit x tending to 0 will make this whole quantity equal to 1. So let's write it down. Let's write it down. See the trick. Let us come down. Yes. Just a minute. Yes. Here, just a minute. Yes, here. So now this will be limit x tending to 0, 1 upon x cube, and into this limit will be 1. In the limit, this will be 1 into limit x tending to 0, x. Now this is x, take common, 1 minus x square, and you have here under root 1 minus x square minus x square. So now this is there. Now what you do is that you rationalize this. You rationalize this one, this portion, the upper portion. You rationalize. Now you see what happens. You have to rationalize this. Otherwise, you won't be able to do it. See, I have to rationalize this portion. So this is, I think I made a small little mistake in doing while doing the calculation. Just a minute. Just a minute. I made a mistake. See, it is plus here, and by mistake I wrote here minus. This has to be plus. Let's correct all this. Let's correct all this. This is plus here. Now let's correct this here. Bring it little down. This will be plus. This will be plus here. So let's do it. Sorry, this has to come down a little bit more. Yes. So now this has to be plus here. This has to be plus here. Now this has to be plus here. Now I have to just do this rationalization of this. That's all. That will do the job for me. That will do the job for me. Now you see, yes, what you do is that, wait, let's do it slowly. Wait a minute. The questions are coming. Wait, yes, now it is here. This is 1 minus x square. This is a minus here. Limit. Let's cut this with this with this. This will become x square. Limit x tending to 0. Up 1 upon x square. Limit this. I can take this inside, no? That's why. Because I had, what I did is, wait, I'll do this here again. Wait, I'll do this here again. This limit is now 1 upon, wait a minute. Let this be, sorry, let this be x cube only. X cube, now 1 upon x cube into x. This, let's rub this also. Let's rewrite x here. 1 minus under root 1 minus x square into under root 1 minus x square plus x square. So this has cancelled this and this has become 2. Now I'm rationalizing this one. So this is now, no, let's write it here. Limit x tending to 0, limit x tending to 0, 1 upon x square So this is 1 minus under root 1 plus 1 minus x square into 1 plus under root 1 minus x square upon under root 1 minus x square plus x square into this one 1 plus under root 1 minus x square. Now this is a minus b and this is a plus b. So now this will become see this will become limit extending to 0 1 upon x square 1 minus x square, yes, right, upon, now you have under root 1 minus x square plus x square into you have 1 plus under root 1 minus x square. Now open up the brackets, this 1 will cancel with 1 and this now will become plus, this will now become plus. So limit x tending to 0, we have 1 upon x square into x square upon under root 1 minus x square plus x square, and then you have limit 1 plus under root 1 minus x square. This x square and this x square goes off. Now what you are left with? You are left with something very easy now for you. Yes, now you are left with limit x tending to 0, 1 upon under root 1 minus x square plus x square into 1 plus under root 1 minus x square. Now put a 0 everywhere, take the limit. So this will become under root 1 minus 0 plus 0 into 1 plus under root 1 minus 0. So this will become 1 plus 0 and then you will have 1 plus 1. So you have 1 into 2, 1 into 2, and answer is 2, half. The answer is half. Now let's do a very good question. Let's do a question on this. Now see this concept of floor functions on this type of question. See, limit x tends to 0, sine x upon x, your greatest floor function, this floor function. Now see, I have to find out the limit. In this, I cannot do whatever I feel like. I need to do this way. See, this is the floor function. That is now, uh, this is already you're aware of. Now see, one thing. The right hand limit x tending to 0 plus the right side of 0. This is sine x upon x. Now see one thing. On the right side of 0, everything is plus. So if you take any angle for your example, देखो right side of 0 पे ये 0 है, 0 के right side पे सब plus होगा, 0 के left side पे सब minus होगा. तो right side का कोई भी angle लोगे, sin 90 ले लो और ये ले लो 90 डिग्री. 90 डिग्री मतलब पाई बाई 2. तो साइन 90 कितना होता है 1 और पाई बाई 2 कितना होता है 3.14 से 3 पॉइंट यू डिवाइड 3.14 by 2. So 1 2 under 2 1 point something, it is 1.5 something. So this is greater. So if you take this example, ये example देख के, if you take this example, see how, what I'm trying to see is whether this sin x upon x is what type of a quantity, greater than 1 or less than 1. मेरा टारगेट क्या है देखना कि sin x upon x ग्रेटर देन 1 है या लेस देन 1 है, वो मैं चेक करना चाह रहा हूँ. मैं कोई भी एंगल ले लिया, 90 डिग्री ले लिया. आई हैव टेकन sin 90. Sin 90 is 1 and pi by 2 is 1.5, pi is 3.14. So sin 90 is less than pi by 2. So in the positive side, for x greater than 0, sin x is less than x. That means sin x upon x is less than 1. And the floor function, you know the floor function. Let's draw the floor function. This is 0 and this is 1, and between 0 and 1 it is, so it will come to 0. Wait a minute, let me make it big. It is like, see, it is like floor function. So this is 0 and this is my 1, and it is in between. See, it is greater than 0 but less than 1, so it's between 0 and 1. So floor function will give me 0. So see what happens. Now you see what happens. Now in this case, so therefore limit, so before I write limit x tending to 0, this greatest floor function of sin x upon x will give me what? 0. So limit, since this is all in, since you have to show this from here, You have to show everything in the working. You have to show all this in the working. This is in your rough to understand. So sine, therefore, limit x tending to 0 plus sine x upon x goes to 0. Now let's take the left hand side. Left hand side means I'm talking about limit x tending to 0 minus greatest integer sine x upon x this. Now in this case, see. Now suppose I take sine minus 90 and I take sine minus pi by 2. This will become minus 1. Sorry. This will become minus 1. And this will become become minus 1.5. And this quantity is greater than this quantity. But there is a minus sign both side. Multiply with minus. So 1 is less than 1.5. देखो साइन माइनस 90 कितना होता है -1 माइनस पाई बाई 2 क्या होता है -1.5 -1 बड़ा होता है -1.5 से तो जब मैं माइनस से मल्टीप्लाई करूंगा इनइक्वालिटी चेंज हो जाएगा ना फॉर x लेस देन 0 सो देयरफॉर ये किसको दिखा रहा है x को ये sin x को दिखा रहा है किसको दिखा रहा है ये किसको दिखा रहा है x को sin x इज लेस देन x हियर आल्सो sin x इज लेस देन x तो sin x बाई x इज लेस देन 1 और फिर वही आइडिया फ्लोर फंक्शन वाला आइडिया फिर वही आइडिया चलेगा फ्लोर फंक्शन का द सेम आइडिया एज द फ्लोर फंक्शन सो नाउ लिमिट x tending to 0 minus this quantity is sin x upon x floor function is equal to 0 therefore you have to write all this again in this case you have to write all this therefore sin x upon x is what is equal to 0 is equal to 0 so limit x tending to 0 plus let me write sin x floor function sin x upon x that is greater than integer function less than equal to x वही है floor function limit x tending to 0 plus sin x upon x is 0 minus sorry this is 0 minus this is 0 minus so limit exists so limit x tending to 0 sin x and greatest exists and you have already found out the limit you have already found out the limit exists so you can write limit x tending to 0 sine x upon x always gives me 0 no problem about it let us see one important problem in this let us see some important problems in this wait a minute okay let's see this problem let's see this problem wait a minute just a minute yes now let's take this problem question limit x tending to 0 sine greatest integer x upon greatest integer x that was whole upon the whole thing now this is this one now see the difference question now RHL limit x tending to 0 plus sine floor function x that is greater than integer function less than equal to x is equal to limit h tending to 0 sine 0 plus h upon sine 0 plus sorry extremely sorry upon 0 plus h floor function now see h I always told you is greater than 0 but less than 1 this is the idea basically h is a very small quantity but greater than 0 now this is coming out to be limit h tending to 0 sine now between 0 see between 0 and h this is coming out to be h and this is coming out to be h now h is this is your ladder floor. This is your 0. This is your 1. H is somewhere here. So h has will have a value here. देखो h क्या है 0 plus h है. h 0 से बड़ा है पर 1 से छोटा है. तो 0 plus h में ये h आएगा. h जो है वो 0 और 1 के बीच में आएगा. फ्लोर फंक्शन होने के कारण ये 0 पे जाएगा. This will become sine 0 upon 0 which does not exist. Which does not exist. इसके साथ कंफ्यूज मत करना एक सेकंड बता रहा हूं डज नॉट एग्जिस्ट इसको 1 मत कर देना डज नॉट एग्जिस्ट ये 0 आया है तो तभी भी लिमिट यहां पे पड़ी हुई है limit is still there but still this value has come because of the floor function has come 0 by 0 which does not have any meaning but now Don't confuse with this one. Wait. Don't confuse with don't confuse with limit x tending to 0 sin x upon x is equal to 1. अरे भाई यहाँ पे x टेंडिंग टू 0 पे आता है और यहाँ पे 0 आया है बिकॉज ऑफ दिस फ्लोर फंक्शन. ये 0/0 है. ये कोई फॉर्म ही नहीं है. विच डज नॉट एग्जिस्ट. दिस फॉर्म डज नॉट एग्जिस्ट. डोंट कंफ्यूज विद दिस. Don't confuse with this one. You people have a habit of confusing this. Sin x upon x. Wait a minute, let me write it clearly. Let me write it clearly. Limit x tending to 0 sin x upon x. यहाँ पे बोलोगे कि you will say that put a 0 here, put a 0 here. अरे we have not put anything. This 0 has come out of this floor function sin 0/0. So this is completely meaningless. This is completely meaningless. Let us see the left hand side. Then you will understand what I'm trying to tell you guys. Let's see the left hand side. Wait a minute. LHL. Sorry. LHL. We are going to see the LHL part of this. We will see the LHL part. LHL. So limit x tending to 0 minus you have sine greatest integer function x, greatest integer function x, that is the floor function. Limit h tending to 0 sine 0 minus h upon 0. This is 0 minus h greater c. Now the ladder is like this. This is your 0, this is your h, this is your minus 1, and h is somewhere here because it is minus h now. Minus h will come to minus 1. So this will be, see, this will be, let me write it down. देखो ये 0 माइनस एच है, 0 माइनस एच है, इसको मैं लिख देता हूँ. और एच जो है वो ग्रेटर देन 0 होता है. माइनस एच मतलब क्या है? 0 और माइनस 1 के बीच में लाई करेगा. और ये है फ्लोर फंक्शन, तो माइनस 1 आ जाएगा. लेट मी रिपीट. 0 माइनस एच इज माइनस एच and 0 minus h is minus h. Minus h will be, h is greater than 0, but minus h is less than 0 but greater than 1, minus 1. So h minus h, let me draw this here properly. This is minus h. Minus h is in between 0 and minus 1. So due to this floor function, this will be minus 1 here, and here also it will be minus 1. So limit h tending to 0, this will be sine minus 1, and here you will have minus 1. So let us see what happens now. Let us see what happens now. Now see, this is now sine. Sine minus theta is minus sine theta. Number of times I have told you. Sine minus theta is minus sine theta. So this will be minus 1, and here it is minus 1. Minus 1 minus cancel. This is sine 1 by sine 1. So the left hand limit exists, but the right hand limit does not exist only. Do not confuse with this one. I'm telling you a number of times. Do not confuse this one with this one. This is a different concept altogether. This is limit x tends to 0 sin x upon x. This is not x. This is not no more h. This is not limit h tending to 0 sin h upon h. ये limit h tending to 0 sin h upon h नहीं है. ये greatest integer function के कारण यहाँ पे ये एक सेकेंड just a minute. Come to this point. Just a minute. Let's come to this point again for a little bit of discussion. Little bit. Yes, here it is. See, limit x tending to 0 in this, is sine x upon x is 1. Fine. But here it is not, see, it is, if you see a little bit here, wait a minute. Here it is. If you see a little bit here, this is not sin h upon h. It is not sin h upon h. It's greatest integer function h upon greatest integer function h. And here, what is here? यहाँ पे क्या है? Sin. What is here? Here sin h upon h है और h tends to 0 ले लो. और यहाँ पे क्या है? Sin greatest integer function h and greatest integer function h है. ये दोनों में अंतर है. Don't try to mix up things. Okay? This confusion is over, I hope so. Now, next is here. Let us do one good question. Another good question, let me take. Yes, very good question it is. Let us take question. Limit x tends to 0 e to the power of 1 upon x minus 1 upon e to the power of x plus 1. Let us see whether what is the position of this limit. What is the position of this limit? Let us see. Now these are very, very good questions. You need to understand these questions very well. Now see. Okay, and the type of, I'm doing this type of question, and the homework for you is limit x tending to a e to the power of 1 x minus a upon minus 1 upon e to the power of 1, let's write a bracket here, divided by x plus x minus a, wait a minute, just a minute. This is your homework. X minus a plus 1. So this you will do on your own as your homework. I'm doing this for you. The concept. Look now. Before I start this problem, I will tell you one concept. Very important concept. Before I start this problem. Here it is. The problem is for me is here. Yes, here it is. See, the concept is, see, I told you x tends to 0 plus, right? So 1 upon x tends to 1 upon 0, and this goes to infinity, and e to the power of 1 upon x at this point goes to e to the power of infinity, and it becomes infinity. This concept should be very clear. Now x tends to 0 minus. So 1 upon x, I told you this will behave like minus 0.000001. This will now behave like minus 1 upon 0, put the bracket here. This will now behave like minus, wait a minute. This will now behave like minus infinity. Keep this idea very clear. This idea very clear. Now, if I put e to the power of this at this point, so e to the power of this will become minus infinity. This 1 upon, in this situation, e to the power of 1 upon x will become e to the power of minus infinity. That is e to the power of infinity by indices rule. This is 1 upon infinity and 0. See the difference here and see the difference here. Why? This is at x greater than 0 and this is at x, sorry, हाँ x greater than 0 and x less than 0. देखो फिर से समझो समझो, ये क्या है, x ग्रेटर देन 0 है, थोड़ा सा x ये x ये 0 है, 0 का प्लस है कुछ, और ये है 0 का माइनस. सो 1 अपॉन x क्या होगा, 1 अपॉन 0 प्लस पे जाएगा, इन्फिनिटी पे जाएगा. e 1 अपॉन x क्या होगा इस केस में क्या होगा, e टू दी पावर ऑफ इन्फिनिटी, वो इन्फिनिटी लेगा. अब x टेंडिंग टू 0 माइनस, तो 1 अपॉन x को मैंने बोला था ऐसे लिखने के लिए, जैसे गलती ना हो, एंड ये टोटल क्वांटिटी को मैं 0 मान सकता हूँ, और ये बाहर माइनस है तो क्या हो जाएगा माइनस इन्फिनिटी. तो इस केस में e टू दी पावर ऑफ 1x क्या हो जाएगा, e टू दी पावर ऑफ माइनस इन्फिनिटी, और 1 अपॉन e टू दी पावर ऑफ इन्फिनिटी, और 1 upon infinity, and that is 0. I think this is clear now. Now come to the question. If this point is clear, then you come to the question. Now let's see what we do with the question. See, now we will do this question. See what we had. Let us take the RHL. Limit x tending to 0 plus e to the power of 1 upon x minus 1 upon e to the power of x plus 1. So if I put 0, it will be infinity by infinity. It's not again a very big problem. So what I'll do is that I'll take e to the power of 1x common here. 1 minus 1 upon e to the power of 1 upon x. मैंने क्या किया, e to the power x कॉमन निकाल लिया इसमें से. जैसे अगर मैं ऐसे लिखूं a minus b, ऐसे लिखा हुआ है, a कॉमन ले लिया तो कैसे होगा b by a, और इसको अगर मैं लिखूं ऐसे करके 1 minus b a to the power of minus 1. What is the problem? देखो, see, it is a minus b. I took a common. Now I have 1 minus b by a. Now b by a can be written as b into a to the power a inverse, and this a is out. I hope you have understood the concept, what I'm using here. Now this is written like this, and let me write down the limit here. Wait a minute. Let me write down the limit here. Let me write down the limit. Limit x tending to 0 plus, again I am taking e to the power of 1 upon x from here common. I'm writing 1 plus e to the, 1 by 1 by 1 by e to the power of 1 upon x. देखो जैसे ये b by a है, b by a, b by a, b by a. The concept is this. This is the concept I'm using. Now this and this cancels out. So you will get limit x tending to 0 plus, you have 1 minus, now this will behave like a inverse e to the power of minus 1 upon x, and this will behave like 1 plus e to the power of minus 1 upon x. Now put, let's rub this now. Let's remove this. Let's remove this, the whole thing. Let's remove this. Now see, this is 1 upon x, 0 plus a. This is coming out to be, look, I did it here. See, so look here. I just did it here. At x 0 plus 1 upon x is infinity. And this comes out to be e to the power of infinity. At 1 upon 0, 1 upon x, at 0 it is coming out to be infinity. This is more important to understand. This point is more important to understand. At 1 upon, at extending to 0 plus 1 upon x is going to plus infinity. This is the point I need to emphasize. And then when I come here, when I put 0 plus, this becomes 1 minus e to the power of minus, you have to 1 upon 0, something like that. Though I'm supposed to write like this. Okay, but for making you understand, I'm writing like this: 1 plus e to the power of 1 upon 0. This I'm doing for all these non-math students. Remember this. Math students already know this concept. They've done it in 11th and 12th. So this quantity will behave like 1 minus e to the power of minus infinity, and this quantity will behave like 1 plus e to the power of minus infinity. Now e to the power of minus infinity, I told you, look here, look here, look here, look here. Where is it? Here. Here it is. E to the power of minus infinity came out to be this, and it came out to be 0. This 0. Wait, sorry. This 0, it came out to be. E to the power of minus infinity came out to be 0. So this idea I'm going to use here and see. Yes. Now I will erase this step because I will not keep this step anymore here. Wait. Let me not keep this step here. Let me not keep this step here. Now you have understood. Now let me bring this step here. Bring this step here. Here. That's right. Now this you have got. So now this is equal to 1 minus 0 and 1 plus 0. So this is equal to 1 by 1 and this is 1. Now let's try the left hand limit. Left hand limit. Now in this case, limit x tending to 0 minus e to the power of 1 upon x minus 1 upon e to the power of 1 upon x plus 1. And now in this case, when I take the limit extending to e to the power of 1 upon x, you have already seen here, तुम लोग यहाँ पे देखा है ऑलरेडी पहले भी हम लोगों ने, जब x टेंडिंग टू 0 माइनस है 1 अपॉन x माइनस इन्फिनिटी जाता है, e टू द पावर ऑफ 1 अपॉन x कैसे जा रहा है, बिहेव कर रहा है. सी दिस, वेट अ मिनट, लेट मी ड्रॉ इट प्रॉपर्ली. तो तब e टू द पावर ऑफ x कैसे बिहेव कर रहा है, 0 की तरह बिहेव कर रहा है एट कहाँ पे, एट x टेंडिंग टू 0 पे. ओके, नाउ कम टू द पॉइंट. नाउ कम टू द पॉइंट. सो दिस will behave like minus infinity minus 1, e to the power of minus infinity plus 1. So this will be nothing but 0 minus 1, and this will be 0 plus 1. So you will get minus 1 by 1 and you will get minus 1. So right hand limit x tending to 0 plus fx here is not equal to limit x tending to 0 minus fx. So limit x tending to 0 plus 0, sorry, x tending to 0, e to the power of 1 upon x minus 1 upon e to the power of 1 upon x plus 1 does not exist. Does not exist. Does not exist at all. Now see one thing here. See one thing here. This concept was the main concept. These two concepts. From here till here. Till here. Wait. Till here. This whole concept was important. This whole concept was important. E to the power of 1 upon x go to infinity at x tending to 0 plus, x tending to 0 minus, e to the power of 1 upon x goes to 0 because of this reasoning. So now you will do this question on your own. This one. Similarly, this question is your homework and you are going to do it on your own. Now you take, what you do is that I'll tell you that a hint. Take h, and here you write a plus h and a plus h once, and then a minus h and a minus h, and then you do this problem. Okay, now let us do some more problem on limits. Let us do some more problem on limits. Some good questions on limit. Now let us take one. Yes, one good question on limit, that is, take this function fx equal to fractional part of x. I hope you remember this fractional part of x. Sorry, extremely sorry. This is fractional part of x, means this is x minus greatest integer x. And I told you this graph, I hope you remember. This was one they never touch. They never touch like this. I have told you this graph. and I have told you this lies always between 0 and this always lies between 0 and 1. Always lies between 0 and 1. Now I want to find whether at any point limit x tending to 0 fx exists or not. Exists or not. Let us find out. Let us find out. Limit RHL. Limit x tending to 0 plus fx 0 plus is equal to limit h tending to 0. You write 0 plus h. This is equal to limit h tending to 0. See, when this greatest integer function come into picture, now don't do it directly. Use this concept of h, a plus h and a minus h. It is easier to tackle the problem, right? To tackle the problem, it is easier then. Now, yes, you write here. Let's rub this here. Let's write here. Wait. Let's write here equal to limit h tending to 0, 0 plus h, and then minus greatest integer function 0 plus h. Now h I have already told you is always greater than 0 and less than 1. Take the ladder. This is h, this is your 0, this is your 1. So this quantity will always go to 0. So limit h tending to 0, this is h minus h, and this is going to go to, this is always go to, between 0 and h it will always go to 0. So limit h tending to 0, h minus 0, taking the limits, it is 0 minus 0 is 0, no problem, done. Now the problem comes with the, now the next part is for limit LHL, that was RHL, limit x tending to 0 minus fx. So you write limit h tending to 0 f 0 minus h. This comes out to be limit h tending to 0, 0, 0 minus h minus greatest integer 0 minus h. This comes out to be limit h tending to 0, this is minus h, and greatest integer minus h. Now the problem is h is always, I told you, greater than 0 and less than 1, but minus h is greater than less than 0 and greater than minus 1. So minus h, let's draw the ladder here. This is 0 and this is minus 1, and minus h is somewhere here. So this minus h will come to minus 1. देखो 0 और h 1 के बीच में है. जब ये माइनस एच है ना यहाँ पे, तो माइनस से मल्टीप्लाई करते हैं तो क्या हुआ, माइनस एच कहाँ पे आ गया, 0 और माइनस 1 के बीच में. तो ग्रेटेस्ट इंटीजर माइनस एच का क्या होगा, फ्लोर फंक्शन है, तो माइनस 1 पे आएगा. यहाँ पे लिमिट पुट कर दोगे, देखो लिमिट एच टेंडिंग टू 0 माइनस एच, एंड ये आएगा माइनस ऑफ माइनस 1 बिकॉज ऑफ दिस कॉन्सेप्ट. तो अब लिमिट पुट कर दो तो क्या आएगा, 0 plus 1, and you are getting 1, and there you are getting 0. See, you are getting 0 here. Wait a minute, we are going a bit fast. Here you see, here we got 0, here we got 0, and here we are getting 1. So the right hand limit is not equal to the left hand limit in case of this is fractional part, fractional functions. So limit x tending to 0 plus x minus x, I write this way, is not equal to limit x tending to 0 plus minus x minus, one is 0 plus and another is 0 minus. They are not. So limit x tending to 0, greatest integer function, ये curly bracket, this is the curly bracket, greatest integer function, sorry, fractional part of function, sorry, extremely sorry, fractional part of function, which is also called limit x tending to 0, x minus greatest integer floor function does not exist. Does not exist where at x equal to 0. Remember, limit continuity and differentiability. I may have forgot to tell you, but I was supposed to tell you, limit continuity and differentiability are point-based property. Limit, note. This is something different. This is something different. Limit, continuity, and differentiability and differentiation are point based property. Point, not domain, not the whole. Suppose कहीं एक पॉइंट पे कंटिन्यूअस नहीं है, तो इसका मतलब नहीं है कि पूरे डोमेन में वो कंटिन्यूअस नहीं है. उस पॉइंट पे नहीं है कंटिन्यूअस, उस पॉइंट पे लिमिट नहीं है, हो सकता है कहीं वहां पे लिमिट हो. ये पॉइंट बेस्ड प्रॉपर्टी है, लिमिट बेस्ड प्रॉपर्टी नहीं है. These are point based property, a point based property. That this is the thing. And I think I have been able to cover most of your typical questions of this.